Hi folks, welcome back to Math with Captain Rod. I'm making this to be kind of an introductory video on how to calculate limits. So when you're calculating limits, and we're going to look at three examples, this is the advice I give everyone. Start by just putting the value in and seeing if you get a number out. And if the answer is yes, you're done. So here you'll notice we're going to calculate the limit as x approaches 2 of 2x plus 1. So just take the 2, put it in for x, see if you get a number out. And you do. We get 5. Done. All right, so that's step one in calculating a limit. Just put the value that your x or whatever number is approaching, all right, into your function and see if you get a number out. If so, you're done, move on. Okay, let's try this one. The limit of this thing as x approaches 3. Now, you'll notice here if we put our number in, 9 plus 6 minus 15. We get a 0 up top, and if you put in 3 here, you get a 0 on the bottom. Now you might think the answer is 0, and you would be incorrect if you did. Or you might think the answer is infinite, also incorrect. Or at least I'll say potentially incorrect, both of those. So 0 over 0 is what we say is not determinate. That's kind of a meaningless thing. So sometimes these things require a little bit of modifying here. Just because you get a 0 over 0 doesn't mean that you can't find a limit. You'll notice that the top of this thing factors. So this is equal to limit as x approaches 3. And I think I designed this to factor into x minus 3 and x, I think, plus 5. And I'm going to double check that. X squared plus 5x minus 3x. Yeah, that's looking good. Minus 15. Yep. And now you'll notice these reduce. This is in fact equal to the limit as x approaches 3 of x plus 5, which is 8. Done. So we were indeterminate. A little bit of factoring got us to something we can figure out a value. Third example here. Sorry about my crummy writing, but limit as h goes to 0 of this quantity, x plus h minus x squared over h. This is an example of what's called a difference quotient. We'll be talking about a lot about that very soon. Now, again, following my standard advice, if we put h equals 0 in, we're going to get x squared minus x squared over 0, which is 0 over 0, which is not determinate. So we go, that's no good. All right, but again, that doesn't mean we're out of luck here. So let's do this. Let's just do some messing around here with this. Okay, limit as h goes to 0. Let's expand this out of x squared plus xh minus h squared. That's what we get when we multiply this out. Don't forget that has to be FOILed. That's not just x squared plus h squared. Oh, I forgot it too. When you do your outer and inner term, you'll end up with a 2xh in that. And then whoops, and then we have this minus x squared again from this, and then over h, which is equal to limit as h goes to 0. You might wonder, do I have to keep writing this? Yes, for it to technically be written correctly. The x squareds now add to 0, so we get 2xh minus h squared over h, and you'll notice one of those h's will cancel out. So if we do that, we're left with 2x minus h. And now as h goes to 0, we get 2x, and we're happy. We're done. Ta-da! Okay, so these are just three examples of calculating limits. Again, you always start by just putting a number in, see if you get a number out. If you do, you're done. If you get something like 0 over 0, then you've got to, I guess for lack of a better way to put it, massage your function or whatever you're working on here. And there's different tricks for that. This is one of the common ones, is factor and divide, or expand and then something will hopefully divide out and stuff like that. There's other types of tricks. There's multiplying by conjugates and whatnot, and then there's trigonometric limits and that. And I'm just going to save that for another video. This is meant to be just an introduction to get you rolling. So hopefully it has done that. Have a great day.